Before we start this video, a large thank you to Friday, Kyle John, Laura Walker, Alfredo, Stormy Blue, and Zinan for their support on Patreon. I hope you guys enjoy the video. And a massive thank you to Halo Burner and Ryan Bellin for their immense support of the channel this month on Patreon. It is always sincerely appreciated, gentlemen, and I hope you enjoy the video. Hello everybody, how's it going? So today, by request of Patrons, I'm actually going to modify our additive scene system. Now, why am I doing that? Before we use the lists, and I mentioned you should use dictionaries if you have a lot of scenes, which I didn't cover, and I should have. But when I was developing that system, as I said before too, it wasn't fully fleshed out in my project yet, but now it has been, and I've tested it, and I'm very content with it. So now we're going to go back and modify what we have here, make it better, and we're going to upscale it so it's much easier to manage very, very large games. And on top of that, if you guys would like to see it, I can show you how to decouple your renderers from your colliders. So if you're playing with a friend and they're in area 4 and you're in area 1, their renderers aren't loaded for you, and this will save you a bunch of memory. Anyway, let's jump in. Okay, I am here in my scene view, and what we're going to do is go to Assets and Scripts, and I'm going to make a new folder here actually, because we're going to make a couple little additions here. Right now, we're actually loading up our scenes individually, and that's fine. But what I've noticed in very large-scale games is for some reason on the deload, let's call it script world scene. Actually, what do we call this? Sublocation? Let me think. World scene sublocation. Actually, let's just call it world scene location. There we go. So when you're deloading scenes, I notice it can cause a stutter if the scene has many game objects. Not so much loading them, always deloading them, and usually only after the first time. Not sure why this happens, but the remedy is to basically separate the scenes into smaller scenes. So delete the update and start functionally dropping your namespace. As is per tradition, make this derived from a scriptable object. This is going to seem maybe confusing to you at first, but let me explain it to you, and I promise it will come together and make a lot of sense, and maybe it will right away. So let's create an asset menu name and call this world scene location, or rather just even world location. What a world location is going to be is just a set of scenes together that make up a location. So, for example, if you have, let's pretend you have a castle. You have the castle walls, the props, the spawners within the walls, and maybe the lighting. And you can put these all into separate scenes, and that lessens the load when you unload them and reload them. And if we put them all in one location under a scriptable object, it's easy to keep track of them and load them all together at once. You can do a lot of other cool things from this place too, like send a pop-up, change the ambience depending on the location that you enter, a lot of cool stuff we know with this. So let's make a list for scenes required for this location, right? So that's every scene you need to load when you load this particular location. So this location could be a room, it could be a part of an area in the woods, whatever, but everything that makes up that particular location is going to be here. And this is what I use in Nef, by the way. This is the exact same system. I'm taking it over here now and putting it in. And I've just become quite happy with it in the last few weeks, so now it's a great time to share it where it's more finalized. So let's make a header for other required locations. Let's make a serializable field, and we're going to make a world scene, location scene set, and make it an array. Now what's this? Well, this first one is all the scenes that you need for this one location, right? But what happens if you can see other locations from where you're standing? Well, that's where this comes in. You need to load all other locations you can see when you're in this one location. And as we know, each location has their own set of scenes that they need. So what this is going to do is load this scene by loading all the ones it requires, this location, and then it's going to load every other location and load their scenes as well. Now, here's a bunch of optional things you can do for fun. Send a pop-up message when you load the area, change the post-processing effects, or change the ambient music. I do all of this, and it's very easy to set up from here. You'll see why after we kind of get into it. So let's make a public list string get required scene IDs for world location. Now, what's this going to do? Well, we obviously need to get the scenes that this scene requires, but we also need to get all the scenes of every other attached location to the array. And lastly, we can make a public list get do not unload list. And this one's quite easy. We just return the required scenes for this location. Because each time you have a location that can't be unloaded, you need to add the scenes that you want to keep loaded to a list, and we just return that location. So we can just iterate through all the locations we have in the game that we don't want to load and send that list. All right, so get required scene IDs for world location. This is where it becomes maybe a bit I'll say hard to fully understand if you don't like nested for loops, because we have to use a nested for loop here. So first, let's make a list. Let's call this total scene IDs required for all locations. So that's the scenes needed for this location and for every other attached location. Okay, so this one here and all the scenes in the array need to be added to this. So first we iterate through our scenes for this location, and then we add it to our total scene IDs, like so. So pretty straightforward, that's it. Now, we need to iterate through each of the required locations and do the same for their scenes, which again sounds pretty clear when you say it out loud, but writing in a for loop for some people might be a bit like, what's that? So let's add the scenes needed for each location that is attached to this one. So we're going to do a for loop, and we're going to go through our required locations, right? But then inside that for loop, we need to also take each required location and add all of the scenes from their list, scenes required for this location. Now, again, this probably makes perfect sense to some of you, but for some of you it might be a bit hazy, but don't worry, it's all going to come together. So we have a list here, and the reason why I'm checking for this list is because I don't want to add them twice. I mean, it's not a big deal if you do, but there's just no need in adding that extra bit of work to the scene loading, especially if you want to put a buffer time between each load request. So what we're going to do is we're going to check all these required locations with a for loop. We're going to say J, but then check the required locations I. Then we're going to get required scene IDs. Whoops. We're going to say, scenes required for this location, .count. And then if our list up here, so if our scene IDs required for this location does not contain what we need here, we're going to add it. So let's say scene IDs required for this location, add required locations I. And we're going to say dot scenes required for this location, J. Okay, there we go. And now I'm going to make a comment, and if we just basically add these to the total, then we can return the total and we're good. So add them to the total and then return the total, and I'm going to say if, and I can check here for already contains, forgot to do that as I was saying it. If this does already contain the scene, then we're not going to add it, and if it does not, we're going to add it. And that's basically it for this script. Now, the only downside is we have to change all of our loading scene logic from an enum to now accepting the scriptable object, which isn't hard at all, but it means we have to rewrite some stuff. So let's make a folder in the data for world locations, and I'm going to show you how to set these up. So now we're going to create, let's go down to our world location scene set. Why did I call it that? I should have just called it world location. That's okay. See, this is what happens when things aren't planned out months in advance. I'm just showing it to you after a few weeks. Sometimes I have to come back and adjust things. So for those of you who just think I write stuff right away and it's just perfect on the first try, that never happens, I promise you. A lot of the stuff has been tested weeks before, months before, used in other games or projects, and I'm just able to basically recall it and reuse it or restructure it in some way. So let's go to the world locations, and what I'm going to do is, what you want to do is make a separate scene for each different thing you're seeing. For example, you can make one for floors, walls, stairs, doors, roofs, bottom trim, top trim, whatever, but I'm going to keep it a bit more light. I'm going to make one for structure, we'll say props, and then effects and spawners. I'll do that for all my areas, because every area has props, every area has a structure. In a real game, every area will probably have spawners, and every area will have, usually areas will have effects. So when I separate all these, right, we can drag them in here, and then we can drag things from our scenes like this and start bringing them down here. Now this whole area 01, sub-area 01 thing, it does work, for the sake of a tutorial, but I'm actually going to give these real names too, so it's less confusing for people who don't just want to see numbers. I'm going to name these rooms randomly based on some vague idea of what they kind of are to me. Like I can see a main chamber there, an entrance hall, a forge, and a throne room, so we'll probably go with something along the lines of that. But what you want to do is basically give each of these rooms separate scenes, right? And a name, of course, and then you want to, we're going to group them all together under that scriptable object that we just made. It's pretty easy. So we got area 00, effects, props, structures, and spawners. Now I could call it that, and that would be fine for the sake of the tutorial, but I'm going to call it dungeon, which is the main area. So pretend this whole map is the dungeon, right? That's what we're going to call it. Could be catacombs, could be whispering woods, like in Neff, it could be whatever. So you could call it that. So the thing will be main area name, and then sub area name, and then number. That's what you want to, so if you want to type it like sub area, if you don't actually have a name for it yet, like this. I find this is a good workflow, but I'm going to call this area 01 dungeon main hall structure. And then we got area 01 dungeon main hall spawners. And then we're going to do the same thing with props and effects. And I won't do all of these on video. I'll just do a few and show you, just really nail it so you can really understand what's happening. But after I rename all of these like that, I then go to my scriptable, and scenes require this location. I just basically copy them, the name, and then put them in there like this. Now, we don't have any other required locations yet, so we got to make the other ones right now because they don't exist. But this main hall for me is actually the hall that goes under and around and beneath all of the entrance hall and the center hall. So I've called that main hall. Maybe should have called it basement or something, but that's fine. I know what it is, and that's all that matters. Now, I'm going to duplicate the scriptable, and I'm going to make this one area 02, and then I'm going to basically translate all of these scenes into multiple scenes. And again, I'm doing this because this is a much better way to not get any stutter when you're loading, especially if you have massive, very detailed scenes. I had to do this in Nephilim because I found that the deload, not the load, for some reason was causing a CPU spike. But weirdly enough, it only happened after the second time the area was deloaded. I have no idea what was up there. If one of you guys in the comments has some experience with this and you know why, I couldn't exactly track it even in the profiler. I couldn't really make sense of it. But this will make it so that problem is remedied. I load so many objects now, and I find it to be fine. Some of my areas have like 6 subscenes, the really, really dense ones, like with a lot of trees, grass, props, and whatever. And I find this to be very, very good. So I'm going to do area 1. We got dungeon entrance hall here, and we got the main hall. And I'm going to just duplicate all of... So you can make an empty scene, actually, do this, and then just duplicate it a bunch and rename it as you need it. That's a quicker workflow, by the way. So create a scene, delete everything from it, and then duplicate it and make all of your scenes and name them. So for example, props, effects, structure, then drag them all in at once, and then start dragging in the headers from your other scenes. But this is also a really, really good reason for you to, when you place props in your scene, to always make sure they're organized. Because if you're a person who hasn't been organizing them, it's going to be a little bit more hectic now to separate them into scenes like this. Obviously, you can still use the hierarchy and search it, so it's still not absolutely hard. It's still pretty straightforward, but it does save you a bit of time if you put that foresight into that previously. So now I have my Area 1 dungeon entrance, and I have my Area 1 main hall. Now I can go to the scenes required for the other one. I can go up here and lock that in place and drag these in, and paste them rather. And then what I can do is, if this location requires the other location, so for example, the main hall does indeed require the entrance hall. So I would add that to its required locations. The entrance hall does indeed require the main hall, so I can add that to its location, like so. And this is basically how it's going to work. Now I will save you the time through the magic of editing, and I will go and do the rest of these really fast, and then I'll come back. Now that I've kind of spoken about this and repeated myself 17 times, I feel like you might have a pretty good idea about how to do this. So alright, there we go. I have everything into these locations, and make sure you go to your build profiles and go to the scene list and add all of your open scenes to it. Otherwise, you won't be able to load them. That's important. Alright, now I am going to just double check all these, and yes, they do all look good. Actually, I think I'm missing one in the atrium. That's okay, I can show you that it works. We can visualize that together. Now, go into your world subscene manager, delete all those lists, because that's fine if you only have like a handful of levels, but man, that's horrible if you got like 40 scenes. So let's make a private dictionary, make it require a world scene location set. I keep accidentally using our world scene location from the enum, and make it require a list of player managers. And this is awesome because you only need this one variable. 50 lists turns into one dictionary with a location set and a list of player managers. So world location scene set, and then a list of player managers, call it players in location within this dictionary. Okay, now watch this. This is fantastic. So we're going to come down to this function here. I'm on line 157. I'm going to scroll all the way up, and this function, by the way, is called generate do not unload list based on player location. Delete everything except for the do not unload world list and adding the world and the return call. And then we're going to make a list of, I just did it again. I keep putting in the enum because the names are so familiar. World location scene set, areas with players active is equal to, and we're going to say a new list, world location scene set. And then we're going to iterate through this using a for each loop. But what we're going to do is we're going to use a pair and key value set here. So in the for each loop where the variable was, type in key value pair, and then open up this little, whatever you want to call this thing, world scene location set, or world location scene set, and a list of player manager variables. So, and then we're going to check the collection. We're going to call this pair, by the way. We're going to check the dictionary we just made. So what this is going to do is it's going to iterate through every entry in our dictionary. Okay, so we also want to clean up any null or empty positions. So say if a player disconnects in the middle of your game, let's make sure that they're actually cleaned out. So we do that by doing a for loop, and we're going to iterate through the pair.value.count. That's the list because it's the value of the dictionary, and count because we're using a list, not an array, instead of length. And then we're going to say if the list.value I is equal to null, we're going to remove at that I. So we're going to say pair.value remove at I. Remember, pair here just means that part in the list. Okay, and then we're going to say if a scene has at least one player, add that scene to the active players. And what we can do here now is say if pair.value.count is greater than 0. So remember, pair is the value is the list here because we're referencing the value of the dictionary, which is the list. So if that's greater than 0 and the areas with players does not contain the pair key, we're going to add it. So if there's no addition here of that being included, we're going to add it. And then we're going to go through a for loop. We're going to go through the areas with players active. And we're going to make a list for scenes required. And we're going to say this is equal to world scene manager dot, whoop, wrong project. This is not an F. We don't need this call. One sec. We're going to reference this actually directly from the world location scene set on the function we made. So let's do that. So I am just going to come down here first and make a for loop. And then we're going to say int j, and we're going to reference the scenes required dot count. And then we're going to say do not unload locations dot add, and we're going to pass the scenes required j. Okay, so what we're doing basically is going through all these areas, and again we can reference this instead by saying scenes required is equal to area active with players I dot get required scene IDs for this location. Remember, we just made that world location set. And then we're adding each scene we take from all of those areas to the do not unload list. Okay, now is player already an area? This one's going to get really tiny too, really awesome. You can delete that entire enum, replace the enum call with our world location scene set. So much more neat now. I should have just did this before, but I was under the assumption of I wanted to wait really, I should say, until I had it fleshed out in Nef, but this did not scale well, so this is going to scale much better. Dictionaries are great, and the scriptable object was definitely the way to do it. All right, we're going to say if players in location contains key area, and players in location area dot contains the player. So again, we're going to check the dictionary for the area. If that's there, cool. And if within that area the player is there, then we know the player is in the area, so we can say is player in area is equal to true. And I'm renaming that to player is in area because that's way more, makes more sense to me. And that is much, much easier than referencing a bunch of enums and going down through it. So now we can go to the remove player from previous location, do a for each loop, and we're going to iterate through our dictionary again using a key pair value. Oh man, Visual Studio, what are you doing? You guys have the 2026 Visual Studio. I updated from 2022, and I regret it. It feels not nice. I miss 2022. All right, let's go through this again, and let's actually check for nulls, as we always do. So we can just actually yoink this code up here, and then we're good to go. So we're going to remove any null entries, but right above that, we're going to remove the player from the location if they're there. So if the pair.value, the list, because the list is the value, contains player, pair.value.remove player. There we go. Looks good. Now add player to new location. Look at all this code. Delete. And now we're going to make this super simple too. It's always nice making things run more efficiently. So if the player in location does not contain the key area, and again we need to make this the world location scene set, not an enum anymore. So if our dictionary does not contain the area that we're referencing, we want to add the area. So we're going to say players in location area is equal to new list player manager. Now, let's copy this. If the players in location does not contain the player, so we're going to check the value now instead. So basically first we're checking for the area. Now we're going to pass the area and check for the player by checking the value. Then we're going to say players in location area dot add player. There we go. And then right down here, let's go back to the project and go to our player manager. And I'm just going to make a header for, no, not accelerated event Visual Studio area. And I'm going to make a public world location scene set. Why did I call it that? Oh my goodness. And we're going to call it area currently. And I'm probably going to rename that off camera. So if you come back and it's called something different, you'll know right away. I'll probably announce it, but player.area currently in is equal to the area that we're passing. So we can keep track of where they're into locally. And let's paste this null check down here too, after we add a player to new location to clean up any nulls in case someone disconnects in the middle of that or after that or what have you. Always can do that. And also if player is null, simply return. Okay, so start coroutine, wait, then activate set active scene. So this actually doesn't even need an enum right now or anything at this very moment in time, because the active scene is actually always going to be your base scene, which is the world scene. So you could pass this world location scene set like this and just reference the location scene set of the world, but it doesn't need to be anything right now. So we'll come back to that though momentarily. So let's erase that. Cool, very good. And now let's save that. And let's go over to load area based on the area you're currently in. So again, replace the enum with our new variable, because this is how we're going to track our areas. And load additive scenes around current area. Let's start with that. So you can see here this is a massive pile of code if you have more than a handful of areas. Well, let's delete everything except for the list and the return and the check if the list is less than or equal to 0. So first let's start by making a list of world scene set. Again, why did I call it that? World locations is equal to a new list of world location scene set. And for those of you who want another in-depth look at this, for whatever reason, I'm going to launch a mini-series on doing just this with netcode. It's only going to be a couple episodes, but I'm going to do this from a fresh project. So we're going to say scenes to load is equal to, and then we're going to want to reference our area, which is not an enum, so let's rewrite this variable as a world location scene set. And then we're going to say, you guessed it, area.get required scene IDs from world location. There we go. Very good. All right, that one's done. And man, that's so much nicer. You see how much lean this is now? How much leaner? So let's change this to world scene management instance.world. So we're going to say if loaded scene's name equals to world, we're setting that as the active scene. So the world scene is always our active scene as it is always present. All right, cool. Now let's go over to our event trigger load scene, change the enum to our new variable of world world location scene set. And that's it, you're good to go. And now let's go back to the project and make sure you drag in all of the areas on your scene triggers. Like see, I've already set up here, make sure you're going to each one and you drag that back in. And now back over here on world location scene set, do a for loop, because I forgot to, after the first for loop in the nested for loop. And you want to reference the scene IDs required for this location. You want to add them to the total scenes, because I didn't do that, even though I said it, I think. So we're going to say if if total scene locations does not contain these scenes, then add them. And what this is going to do now is give you the entire list, because if you don't add this bit of code, then you're only going to load the initial scene that you pop into, and that's not what you want. All right, there we go. And then we can do this here. Okay, let's jump over to the world scene manager, and we're going to go down here, and on the scene events, we have to change this a bit. So first off, under onload and load, delete the scene is loading and scene is unloading. We're going to move that somewhere. This is important. And then down here under load complete, delete the thing that clears the list if it's less than or equal to 0. And then under onload complete, delete the thing that clears the list if it's less than or equal to 0. And then that's it. We're good. Minimize this. And now we're going to go and edit our load and unload additive scene calls. Under load additive scene, right before we make the call for loading the scene, say scene is loading is equal to true. And then under onload additive scene, do the same thing, but make the call for is unloading scene equal to true right before you begin loading the scene. And then over here on onload additive scenes coroutine, what we're going to do is we're going to make a float for wait time. I'm going to default it at for unloading scenes 1.0, but I'm making a call here. If you're in a loading screen or players are resting at a site of grace, if you allow that, make the wait time 0. Now we can do the loading screen thing right away. You can see here if we go to our player UI loading screen manager, all we got to do is make a function that returns whether or not the loading screen game object is active. You do this by making a public bool loading screen is active, and what we want to do is return the status self of the loading screen game object. And that will give us a yes or no. Okay, let's go back to the world scene manager, and we can say if the loading screen is active, we set the wait time to 0, so there's no buffer. We just have a wait time, so there's no overload on your CPU while doing this. But I use a wait time of 0.1 in F is totally fine. I'm just putting it 1 here for an arbitrary number. You can play around with what works best for you. So while scene is loading or unloading, yield return wait for seconds wait time. And then we're going to say while loading queued scenes to load is greater than 0, we're going to wait. And then right here, we're going to say do not, while queued scenes to load, basically do not unload scenes while we are loading scenes right now, because the things that you're trying to unload might be added to the do not unload list. So this is just a more efficient way of doing it. It saves a bit of memory. Not absolutely important in some circumstances, but here it's just better to call it. So if queued unload scene IDs I is equal to null, then what you want to do is say unload queued scenes to unload, minus, and then continue. So take it out of the queue and continue. And again, I find a pretty good unload wait time if the scenes are big, is like 0.5 seconds, but if they're small, 0.1. You can even adjust it per scene if you wanted to and get it from that scriptable object. That'd be kind of cool, but that's up to you. Now we're going to say scene is loading while it's loading or unloading. Wait for the wait time, and then we're finally going to say queued scenes minus, and if queued scenes unload is less than or equal to 0, we're going to set it to 0. And don't forget to keep your unload additive scenes coroutine is equal to null after all this is over. So this is it for the unload additive scenes coroutine. Now we do the same thing for the additive scenes coroutine, but with a minor difference. Obviously the wait time, as I said, is a little bit less. Like I use 0.1 in F, and this is fine. Even my scenes are massive because the deload is what causes a potential stutter in my experience. So again, if your player is in the loading screen, you set the wait time to 0 because there's no need to worry about stutter if a loading screen is over your game. And then while the scene is loading or unloading, wait for seconds. And then if the queued scenes I is equal to null, you want to deduct from the counter and continue onward. Then we're going to copy this is loading or unloading, and after you load the additive scene, wait until it's finished and then deduct from the counter. And then we're going to check and say if queued scenes to load is less than or equal to 0, queued scenes to load is equal to 0. It should never be less than 0, but I'm just going to put it here just in case. We're going to say queued scenes to load is like clear, sorry. There we go. Okay, now if I go into the scene here, I want to show you first because I think I forgot to add the corridors, but let's go up the hall here, and you can see that the scenes absolutely do unload, and they're taking a second between each one. Very good. So now if I were to run back down there after they've all unloaded, I'm going to show you. I'll wait a second, and then they'll come right back. Likewise, too, if I did this in the middle of them deloading, they would come back and stop unloading. But let's go down here. Boom, there we go. And you can see here, look at that. But if I go out here, boom, the corridor is missing. Well, why is that? Well, if I were to go to my, I believe I call it atrium, I don't have the corridors added to a required scene scriptable. So I have dragged that in, and now if I go and actually go back to the project and run back upstairs and then come back down, you can see that it does actually load in. So all these scenes are linked from these scriptable objects. And I think this is a much more elegant system and scales much better than what we had before. Not that what we had before was bad in any sense of the word, but checking all those lists is a great way to have human error. So this kind of mitigates a lot of that. So with most of the stuff I show you guys, again, I've had time to test it in advance, and I've had time to go through my own game and then come back and show you later. But with the World Scene Manager, that was a request I had while I was actually in the middle of developing it. So when I come back and polish it, I want to show you guys the polished version too, because it's definitely much better now. So next up by request, and again, if you guys have more requests, I've seen the comments. We got ranged AI, I'll do that. We got spell AI, don't worry, I'll do that too. We have separating the renderers and the colliders so that if you have a person in your game and they're really far away from you, when they go through a level or an area, the renderers don't pop up for you but pop up for them. I'm going to cover that next, and then if there's no more requests and nothing that I feel that fits into that category, I will start getting into those other ones. The reason why I haven't revisited AI just yet is because when I get into it, I want to do a bunch of episodes right in a row and not cut away and come back and cut away and come back. So I'm trying to figure out everything else that everyone wants before getting back into that. As always, I hope you have a very lovely day, a very lovely weekend. Thank you to my patrons for keeping my lights on. Thank you to the people who take the time to like and comment on the video. You are sincerely appreciated. Have a nice day. I'll see you guys next week.